Hello guys, you're welcome to another one of my videos. Now in the last video we talked about variables and we talked about slices. So in this video we are going to be talking about structs. So what are structs? Well, structs are simply some data structure that allow you to keep related data in a specific place. So for example, let's say we wanted to model some mathematical construct. So let's say we wanted to have like a point. So we know a point is usually something that has an x and y. So what can we do with that? Well, the way you declare structs is you have a struct called points, just like that, and so you have to specify the properties, which are simply the members that are part of the struct. And so for a point, we know we can have i32, not in32, and we can also have y of an i32. Now the question you might be wondering is well, if structs can actually contain data like this, does it actually make sense for a point to just be a point of integers? You know, we can have like a point of float, a point of, I don't know, whatever. So does this actually make any sense? And well, I'm gonna show you guys how we can actually make this a little bit generic using generics, of course. And so, but let's just take a look at how we can actually instantiate this point. So we can say let p equals to point, just like that. Now as you can see, we have errors, and let's just take a look at the warning. And the error you have here is I don't know, this is not showing me the error, damn it. Alright, anyway, so the error we're getting here is talking about we haven't filled in the arguments inside of here. And how do we do that? Well, that's actually simple. We just say x equals maybe 20, y equals 30, and that's pretty much it. That's how you create or declare a struct in Rust. Now in order to access the members of this struct, we can actually do that in a pretty simple way. So if we try to print this, we could actually do the x, damn it, the x to be p.x, and let's just print the y2 by doing p.y, and just like that we can actually print out the values of our struct. And we have a beautiful error. That's because I have px. What the hell is px? Anyway, let's run this again, and this should actually work this time. So we have x is 20, y is 30. Now you might want to print out the struct because, you know, the struct might have a bunch of fields and you want to just see the contents of the struct in itself. So what we can actually try to do is print out the struct in itself by just, you know, printing out p, if I can. Yep. So just try to print out p, and what do we get? Let's see, we have a bunch of errors because of course we cannot use the default formatter to do this. So let's try and see if we can actually use the debug formatter. Why the hell can I not type? Anyway, so we try to use the debug formatter. Let's see what we get, and it still doesn't work. Well, earlier when we try to use it for arrays, it actually worked. What the hell is going on here? So you can see here it says the trait debug is not implemented for point. Now you might be wondering what the word trait is, or debug, or whatever, but I'm gonna explain that in subsequent videos. So but just go to the top here, and we're gonna have a trait here. We're gonna derive the debug trait just like that. Now what this is going to do is to allow us to print out the values of the contents of this struct. So if I save this and I try to run the program now, this should actually work. And now you can see that it prints out the point and it prints out the contents of the point. Now we could also do the pretty printing bullshit and just run this, and we're gonna get the pretty nonsense of how we just, you know, it looks more like how we created the struct in itself. So that's how you print out a struct, and as you can see, you can access the values of the struct by using the dot notation. Now I also wanted to point out that with every variables in Rust, you discover that if you hover over this is actually what you call an immutable variable. So if I try to assign a value to it like this, you're gonna see that this is not gonna work. Okay, it's gonna tell me that the struct is immutable, and so you see it's not gonna work. So the way to fix that is just as we fixed every other thing. You can see if I set this as mutable and I try to run it, this is gonna work. So you're gonna see 10 and 30 right there. Now, one other thing you have to take note of when you're working with structs is that once you set this as mutable, you can actually mutate all of the contents of the struct. So that's one thing you have to remember. Now, something else I haven't talked to you guys about are functions. I think I should just cover that right now. So functions in Rust are simply, well, functions in every other programming language, but basically what functions are, they allow you to encapsulate some functionality, some little pieces of code. And functions are actually pretty important when you're working with Rust, because Rust doesn't have classes and things like that. All Rust has are structs, enums, and functions, and that's pretty much it. So now, how do you create functions? Well, it's just the same as you declare this main function. First of all, you can have a function. I'm just going to create a function with some weird names, and you can see now if I try to, so if I want to use this function print-ish, right? That's a pretty cool name anyway. So if I try to use this print-ish function, the way I'm gonna do that is I'm just gonna call the function print-ish, just like that. Now, as you can see, this is the snake thing, just as Rust loves it. So Rust loves anything that has to do with snakes. So just make sure that your function names are actually snake-ish. So if you try to do this, for example, Rust is gonna be pretty mad, and it's gonna tell you that let me just show you. I think I've showed you guys this before, but I'm gonna show you again. And you see, this is actually gonna work, but it's gonna complain. Okay, it's gonna give you a bunch of warnings and tell you that it doesn't like camel case or whatever, that it needs snake. So as you can see, it wants the snake case. So make sure that you change that to be snake case. Most of your functions should just be snake case, and just like that. So something else you have to take note of. So what I want to show you guys next is how to bind functions to structs. So for example, we know we have a struct here. So let's say we wanted to do some things on this. So the way we could do that is we could have a function to add the members of this point together. So we could have add point, or I'm just gonna call it add members. It's pretty hard to name a struct, to name functions, sorry. So I'm gonna say I want a mutable reference to what is this? So I need to give it a name, p, just gonna say p, and it's gonna be a mutable reference to the point. So this is an argument to this function. Now what am I trying to do here? I'm simply saying that I need you to add the members and return the result of whatever you've added. And so in order to do that, we have to use this arrow notation and say that this actually returns an i32. I'm returning an i32 here because I have i32s declared for my points. So the way to do this is actually really simple. I don't even know why I declared this as mutable. It doesn't matter because I'm not going to be assigning values to this. So I could just do p.x multiplied by plus p.y, and this is gonna work. Now another way you can actually do this is to just remove the return statement and remove the semicolon, and just that's pretty much it. So if this is the last statement in your program, this is going to return whatever this value is, and to use that is pretty simple. All you have to do is call add print line members. You can just do add members and then pass the the point inside of there, and you have to pass the reference to the point because we're getting the point by reference here. Now you might be wondering why I'm actually passing a reference to the point, and I'm gonna explain to you in a minute why. Okay, so you can see if you add 20 plus 30, you get 50. Now if I didn't pass in a reference and I instead decided to pass this by value, I probably should have explained this when I was explaining about variables, but it was kind of difficult to explain, you know, passing things by values and all. Now if I run this, you see that this is going to actually work without any issues, but let me show you the problem with doing this. Now if I do print line and I do p, so let's say, you know, I just added all the members of the p the struct, the point struct, and I wanted to print out the point in itself, so I'm going to use the debug flag or whatever the hell they call it, and then I'm going to pass p here. Now you're gonna see that we're gonna get an error, and this is not gonna work. All right, now why the hell is this? I mean, you're probably like, what is going on? I mean, I just, you know, added members and I'm trying to print the p, and this shit just, you know, it's just wilding out. Now the reason the compiler is not gonna work is that it's gonna say, you see, it says borrow of moved value p. Okay, now we're seeing something new. What the hell does it mean by borrow? Well, we didn't borrow anything here. Actually, we did. This print line statement, like I told you before, actually is going to take this by reference, and so we are trying to borrow this value, but it's saying that the value has been moved. Where moved? What did we move where? Well, actually it turns out that if you want to use a variable, if you assign a variable to another variable in Rust, you're actually moving that variable inside the other variable. So especially when you're working with structs and some other things like that, so calling this function without a reference simply means I am moving this p inside of this function. Now when this function executes, it's just going to drop this variable, and the variable is not going to exist anymore, and I cannot use this variable anymore because it has been moved inside of this function. Now since I moved this variable inside of this function, I cannot use the variable here anymore, but I can pass this by reference, and if I do that, then what that means is that I am simply passing by reference, and I can still use both of the I can still use this. So simply this is just like I'm borrowing the p here, and after this function returns, the borrow would have been returned back to p, and I can still borrow again. By the way, you can borrow a variable multiple times. Just make sure that it is not immutable. It is not mutable borrow. If you borrow mutably, then you're gonna have a lot of issues. And but if you just borrow immutably, like for example, I could have like let p1 equal to p, let p2 equals to p. Now you're gonna see that this is not gonna be an issue. If I try to run the program here, this is gonna actually work without any issues at all. Now the reason this works is because this is called an immutable borrow, which means p1 and p2 can only reference you know, whatever is inside of point. They cannot actually do anything with it. They cannot actually manipulate the contents of point. But if this variable is mutable, and I try to get a mutable reference to p, then we're gonna have a problem when I try to use p3. Okay, so let's say print line p3, and then I have to do that debug thing, p3. Now running the program, we should get a bunch of errors if I did it right. Oh, and we don't have a bunch of errors. Oh yeah, that's because, let me show you, that's because I didn't change any value inside of there. So let's say we change one of the values inside of p3, and then we try to use it again. We still don't get an error. Okay, well, definitely Rust is crazy, but I'm gonna show you, I'm gonna make sure that we get an error. Just give me a minute. Okay, here we go. Let's see. Yeah, there we go. So you can see just by reordering the instructions, we get an error, and you're probably wondering why. Well, the reason is because, first of all, there was a borrow here. This was just an immutable borrow, so this shouldn't really be an issue. But as soon as I got here, I borrowed mutably, and now this is where we start getting issues, because when you borrow immutably, you cannot borrow mutably anymore, or basically what this is I have already assigned some values here. These two are a reference to P. Now I'm creating a mutable reference to P, which means that whenever P is modified, these guys are going to be probably pointing to garbage. So and so this is why it's telling me that I cannot actually, let's just take a look at the error in itself. So you see, cannot borrow P as immutable because it is also borrowed as mutable. So that's pretty much so it's just a crazy thing going on with Rust. Just make sure that most of the time when you're working with mutable, you're working with immutable variables, and absolutely only use mutable variables when you need them. So that's just one thing you have to take note of. Now also, one more thing I wanted to show you guys is so let's assume we wanted to square our point. So we could do square point, and we pass in a immutable reference to point. And the reason we're passing a immutable reference to point this time around is because we want to actually modify point. Now this is gonna work, okay? So this is just p.x multiplied by equal to p.x multiplied by p.x, and p.y multiplied by p.y. Now this is gonna work. Let's just take a look. Okay, so I could do square point, if I can type. So in order to square this point, I just need to pass in a mutable reference to P, just like that. And now I could print my P, and this should actually work without any issues. So you see that it actually works. So it's complaining about this function has never been used, add members, and then after running it, you get P is equal to 400 and 900, and we were able to square this. Now if you've worked with the C programming language before, this is probably going to be familiar to you. You know how we just create functions that manipulate structs, and you're going to be like, yeah, okay, I've seen this before. But actually we have a way to bind functions to structs. So this allows us to actually organize our functions so that they work for some specific types or specific structs if you want. So the way this works is actually we're gonna have to define what is called an implementation block. So it's just implement point, and what I can do is have this function inside of this, well, something like this, I guess. This function inside of this implementation block, and what I could do is remove the square point and just have square like that. Now I could also reference most of my variables with what I call self. Okay, I have to remove this to make sure that that actually works. Now also I'm gonna have to remove the P because we're not using P anymore, so we're gonna have to replace P with self, and this is gonna work similarly to the way the other function worked earlier. But the cool thing about this is that now we can actually just call P, P the square, and this is gonna work just like before. But now you can see we're now working with something that looks a lot more like Java or C++, and as you can see, this actually worked just exactly the same. So now we can actually, whatever other data structure we decide to declare or define is not going to be polluted inside of our module or whatever you want to call your source file. So now everything is organized, and we know these functions are actually belonging to point, and we can do whatever hell we want with it. Now if you're wondering what self is going to be pointing to whatever point instance you are trying to manipulate. So another thing you can do is create what we call factory functions, where you have creating a new point, So we could have x I32. I said x, I typed y. Anyway, y I32. Now what this is going to allow you to return is a point in itself, and what this is, you could just type in point. Remember what I told you about having a last value inside of a function, and you don't have any return and whatever, you just have it like this. What that does is it's going to return that particular value or expression. It's going to make it the return type. So here we just have x, y. And you're probably wondering again, okay, first of all, we're seeing self in capital letters here. Again, self is actually pointing to the implementation for that particular struct you are implementing. Now also you see that earlier when I declared the variables, all I had was something like this, x colon y colon. Now if the arguments correspond with the name of the fields of the struct, then you can actually do that. So that's gonna work. So now the way to create a new point is just going to be point new, just like that. And let's take a look if that works. Yeah, so it expects 2 arguments which we can pass in, 300, 500 and all, and everything still works as usual. We can run the program just to make sure that everything works, and as you can see, this actually works pretty great. So this is where you put implementations for your point struct, and this allows you to properly organize your data. And there are better ways to actually organize data though, because after creating stuff like this, you can actually put this in its own file. So you're probably gonna have like let me see, you're gonna have like the point.rs, which actually make a lot of sense. You know, you can keep all your data inside of their own file, and then you can go back to here and just have mod point. I believe that's what you're gonna call it. Yeah. And now I think if you run it, this should actually not work. Yeah, so but this should. Oh, damn it. What is this? What is this? Yeah, so it said this point is private. So exactly what I was gonna explain to you guys about modules, but we're going to talk about modules more in depth in some other video. So if you have to make your structs public, and if you do that, then this should actually work or not. Damn it, all of this is actually supposed to be public. Oh, by the way, you can see that we actually create public using pub, like pub, like that. If this doesn't work, I'm gonna freak out this time around because I hate this compiler. Anyway, this actually works, and you can see that. So this is how you keep your data separate, so you can have your own point struct inside of its own file. But remember, you have to make you have to import it using this mod point, as you can see, and then you have to make everything you want to be public inside of this module. You have to actually add this pub modifier, which makes, you know, an item visible to others. That's a pretty nice description. I think I should learn English from the Rust developers. I'm gonna find one of the developers so that I can actually learn proper English from them. All right. Anyway, I think that's pretty much it for structs. And yeah, so this is how you can actually declare members of a struct. This is how you declare member functions for this struct. This is what we call like a factory function to just create a new struct. And this is just a member function that actually manipulates that particular struct. Now also something else I want you guys to note, okay? Now I want you guys to understand that whatever you pass into here, so this is just like a shortcut for a function that you just pass a point inside of it. So if you have something like this, if you don't have like a reference or a mutable reference to that particular so let's say I wanted to see I wanted to print out like the addition of both of the values of my struct of this point. I could do from sum, for example. Now I have to take a reference to self, for example, and then I'm gonna return I have to specify my return type using this arrow notation, as you can see, and I return an I32. Now this is going to return self.x plus self.y. Now put a semicolon there. Like I said, you can omit the return and then the semicolon, and this is going to do the same thing. All right, so now if I call sum, you can see that this is actually going to work just fine. This is going to work just fine without any issues whatsoever. You can see the sum of that is that. Now let me show you one little issue with this. Let's just say we wanted to subtract the y from the x. Now we pass in self. Now as you can see, I didn't put a reference. I just had I32, and that was pretty much it. Now I'm going to do self.x minus self.y. Now you save that. See, there's no issue, no problem, everything looks fine. Okay, let result equals to p dot subtract, and then print line result. Now res. Okay, that doesn't look like an issue. Let's just run this and see. Holy shit, what is going on? I mean, what the hell? You're probably looking and you're like, alright, this is crazy. Now let's just take out the error. I just wanted to show you guys how crazy the Rust compiler is. Alright, so you see here it says point new move occurs because damn it, borrow of move. Exactly where did we move? We didn't move shit. Actually we did. Alright, so where we did subtract, what we did here was we moved the point inside of this function. Like I told you, this is just like a shortcut, or you can call it syntactic sugar, for actually calling sub p. Just to show you what I'm trying to say, you can actually call this function without actually using this dot notation by doing point p. Sorry, sub. Damn it. And you have to pass in the p now. And you can see that this actually is the same as what we had, but this is a crazy way of writing code. I mean, who would want to write code like this? So that's why the shortcut actually exists, where you can actually just call p the sub. But now what happens is that p gets passed inside of this function, and it has been moved inside of it. So if you want to make sure that this is not moved, you have to pass this just like that. And once you do that, this shouldn't really give us any of an issue, and our program should compile pretty fine, and we are good. So I think that should be the end of this video, and in the next video we are going to be talking about enums. I wanted to cover enums in this video, but I think this video is already long enough, and yeah, just see you guys next time. Bye bye.